Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am your chemistry teacher here. Hope so you all are fine. Today we discuss about the ionization energy or the ionization potential, which is mentioned in chapter number 3, periodic table and the periodicity of the properties. Now we are going to start the ionization energy, or also we can say that the ionization potential. So first of all, we discuss about the definition that the minimum energy required to remove the valence electron from the outermost shell of the gaseous atom to form the positive ion is called the ionization potential, or the ionization energy means that the minimum energy means that the less amount of energy is required to remove the valence electron. What are the valence electrons? Valence electrons means that the electrons which are present in the valence shell or in the outermost shell. So when we remove the valence electron, so for that purpose we require the energy. We require the energy. So the energy required to remove the valence electron from the outermost shell of the gaseous atom, and when that electron is removed from the valence shell or the outermost shell of any atom, so it form a positive ion. When electron is removed, when the loss of electron occurs, so positive ion formed is called the ionization potential, or the also we can say that the ionization energy. Now explanation means that when electron is completely removed from the valence shell, from the outermost shell, when the electron is completely removed from the outermost shell of any atom or the gaseous atom, so that atom has been ionized. Ionized means that in that atom having the charges positive or the negative. When electron is removed, so atom having a positive charge, and when electron gained, so that atom having a negative charge. So this process is called ionization. When an electron is removed, so from the outermost shell, so that process is known as ionization. That process is known as ionization, and for that purpose or process we required the minimum energy, so that form the ionization energy. Then we discuss about the general equation. The process of ionization can be represented by the following general equation, where A is any gaseous atom. So we having the general equation like the atom, and that atom having the valence electron. So when that atom electron is removed, so it form a cation plus electron. Cation means that the atom having a positive charge. So for atom we use the capital letter A, then we use G. G means that in small letter G means that in a gaseous atom, when that atom remove its valence electron, so it form A plus. A plus means that it form a positive ion, or a positive ion is known as a cation plus electron is removed. So we discuss the ionization energy. What is the ionization energy? When an electron is removed from the valence shell of any atom or the gaseous atom, and for that purpose we require the energy, and for that energy we remove the valence electron from the outermost shell and they form a positive ion, and this is known as a ionization potential or the ionization energy. Then we are going to discuss the unit. Ionization energy of an element is measured experimentally in joules or kilojoules per mole. We have a specific unit for the ionization energy like joules or the kilojoules per mole. Now we have many types of ionization energy: first ionization energy, second ionization energy, third ionization energy, and so on. So we discuss one by one. First we discuss about the first ionization energy. So the energy required to remove first electron from the outermost shell of an atom is called the first ionization energy or the ionization potential. When an electron is removed from the valence shell, or we remove the first electron which is present in the valence shell, so that is known as the first ionization or the ionization potential. We have specific examples like the sodium, magnesium. In case of a sodium, sodium belong to group number 1. It means that its outermost shell consists of one electron. So when that valence electron is removed, so for that purpose we required the energy. So when we give that energy, so in that atom, positive ion or the valence electron is removed and form a positive ion Na plus electron, and for that purpose we require the energy like 4 plus 496 kilojoule per mole. Now we discuss about the second definition of the ionization energy, like the magnesium. Magnesium belong to group number 2. It means that its outermost shell consists of two electrons, and in this case, in that two electron, first one electron is removed, then the second electron is removed. So when that first electron is removed, so it's known as the first ionization energy. So a magnesium form the magnesium plus one electron. In case of a sodium or magnesium, when first electron is removed, so it form a first ionization energy. Then we discussed that the second ionization energy, when the first electron which is present in the valence shell, or that having the valence electron, and when that electron is removed, so it form a first ionization energy. Now we discuss about the second ionization energy. The energy required to remove the second electron after the removal of the first electron is called the second ionization energy. When first electron is already removed and now turn, and the second electron is removed, so it's known as a second ionization energy. Like we discussed that the magnesium in Mg plus means that in this magnesium one electron is already removed and it form a positive ion Mg plus, which we discussed previously in the first ionization energy. In first ionization energy, we discussed that the first electron in magnesium is removed and it form a Mg plus. Now, but we know that the magnesium belong to group number 2, and it means that its outermost shell consists of two electrons. So when first electron is removed, so it's known as first ionization energy, and when the second electron is removed, so it's known as a second ionization energy. Now in second ionization energy, like plus 1450 kilojoule per mole, means that the second ionization energy of magnesium is greater than the first ionization energy of the magnesium. So it's the increasing order or the increasing order of the ionization energy, like the fourth shell or the fourth electron having high energy than the second, then the third ionization energy, and then the second, and then the first, and so on. Then the factors affecting the ionization energy of an atom depends upon the following factors, like the first one we discussed at the nuclear charge. These are the factors which are affecting the ionization energy. First one we discussed at the nuclear charge. The larger the nuclear charge, the greater the ionization energy. Nuclear charge means that the nucleus charge. So when the atomic number is increased, so the nuclear charge, the nucleus power or the nucleus charge is also increased. So when the nucleus charge is increased, so we required greater amount of energy to remove the valence electron. So for that purpose, greater the ionization energy. These nuclear charge or the ionization energy are directly proportional. So when the nuclear charge is increased, so for that purpose ionization energy is also increases. Now we discuss about the shielding effect. What is the shielding effect? Means that the inner electrons form a shield. the outer electrons from the nuclear charge and reduce the hold of the nucleus on these valence electrons. Means that the inner electrons form a shield to the outer electrons and reduce the hold of the nucleus on these valence electrons. So when greater the shielding effect, the less the ionization energy. Means when the number of shells increase, so the shielding effect is also increased, and less amount of energy is required to remove the valence electron from its outermost shell. Third one, we discuss about the atomic radius. The greater the distance between the nucleus and the outermost electrons of an atom, the less the ionization energy. Same in the case like the radius. Also, when the number of shells increases, so for that purpose, less the ionization energy. Then we discuss about the sublevel. An electron from a full or a half filled sublevel requires additional energy to be removed when an atom having completely filled electronic configuration or the half filled. So for that purpose, additional energy is required to remove that electron from the valence shell.